All right, hello again. Mr. Burkhart here, working on 2F, direction of force. Try to keep these videos to between 6 and 10 minutes. So we want to draw free body diagrams. This bulldozer with a big mass is pushing this cube with a smaller mass across rough ground. All right, so first we want to do a free body diagram of just the bulldozer. So the bulldozer has got a bigger mass, so it's got a force of gravity like that. And then the cube has got a smaller mass, so it's got force of gravity like that. And so they each have a normal force pushing up on them, which will be equal in magnitude to the weight, right? So this line should be the same as this line in these cases. All right, so looking at just the bulldozer, what's pushing on the bulldozer? Well, the cube is pushing on the bulldozer. It's like a normal force, but we're going to call it the force of the cube on the bulldozer. And then the ground is pushing on the bulldozer. So right, the wheels grab the ground, and the ground pushes the bulldozer forward like this. So this will be the force of the ground on the bulldozer. All right, so what's pushing on the cube? Well, what's pushing on the cube is the bulldozer. The bulldozer is pushing on the cube, and then there's friction of the cube scooting across the ground in the opposite direction. This is a bulldozer push. All right, so notice that these arrows are not the same. These arrows are not the same because the system is accelerating. It says it's speeding up. So in the horizontal direction, we have to have lopsided arrows to show that we have a net force. And then for the whole system, we look at the force of gravity in the whole system would be the sum of the masses times little g. And so there would be a giant normal force here for both of them. And this here, what's pushing us is the force of the ground on the bulldozer, right, is the force that's pushing us this way, the force of the bulldozer basically. We're out pushing the system, and then there's a little force of friction here. All right, so in the blanks above, write an equation stating Newton's second law for each one of these. So here in the horizontal direction, we have the force of the ground minus the force of the block equals big M, A. Here we have the force of the bulldozer minus the force of friction equals little m, A. Here we have the force of the ground minus the force of friction equals both masses, A. Okay, and that's off camera. Perfect. All right, now I've dragged it up to the camera so you can see it. All right, so I did that. So use the equation created for the external forces on the system to figure out the acceleration. So basically, the force of the ground minus the force of friction equals the mass of the system times A. So it's given that the force of the ground is 5,000 minus the force of the friction is 2,000 equals the mass of the system, which is 1,500, times A. So this would be 3,000 equals 1,500 A. A equals 2 meters per second squared. All right, that's F. We're at 4 minutes. So let's take a look at G. G, I am missing G. Here it is. All right. G has got a lot to it, so I'm actually just going to stop this video and make a new video for G. Stop.